Welcome to my YouTube channel. This is the second video I'll be posting, and today I'll be talking about the kinetic theory of gases. Okay, but now let me talk about a little bit of history of this. I'll be talking about a scientist in the year 1827. Okay, his name was Robert Brown. And Robert Brown, he suspended a pollen grain. Okay, pollen grains are tiny structures produced by male plants. Okay, I'm not going to be talking about pollen grains that much now. Okay, so Robert Brown, he suspended this in a drop of water, and he noticed that the movement was somewhat erratic. By erratic, I mean scattered. By scattered, I mean zigzag. The thing was just moving randomly. Okay, so he assumed that random motion was due to the collision between this pollen grain and the water molecules. Okay, so did we get that? All right, so let me continue. Now, before I start with the kinetic theory of gases again, let me just say what the kinetic theory of matter assumes. So let me write this kinetic theory of matter. So just assume it's like from here to here. Now, the kinetic theory of matter assumes that all matter is made up of tiny particles, atoms, molecules, or ions. All matter is made up of these particles, and these particles are in constant motion. That means they keep on moving. They are in constant motion. They move constantly, and thus they possess kinetic energy. Alright, so now I'm going to be talking about the kinetic theory of gases. I'm going to be talking about 5. Alright, 5. So I think I should just alright, so let's continue. Yeah, so let me talk about the kinetic theory of gases. Now, okay, so the gas molecules, number one, the gas molecules move randomly. Okay, molecules move randomly in straight lines and they collide. Now, what is collision? When they hit each other with one another and with the walls of their container. Let me just explain this. Okay, all right, so now let's say this is the container now. Okay, and these are two gas molecules. All right, now when they keep on moving in straight lines randomly, now since there are several of them, let me use several molecules. Now, since all of them are moving randomly, at some point, several of them will collide. Like at points, regular intervals, they collide with one another. And then, let's look at the two molecules again. When two collide with each other, they bounce back. That's to show that their collision is perfectly elastic. That's number 2 of the kinetic theory. Their collision is perfectly elastic. Oh, there you have it. It's perfectly elastic. Now, I said here in theory 1 that they also collide with the walls of their container. Now, when they hit each other, keep on moving randomly. Now, they also collide with the wall of this container and they bounce back. Now, since several of them keep on colliding with the walls of the container, it exerts a certain force on the walls of the container by constantly hitting it. Now, this force is called the gas pressure, and it increases with increasing temperature. Okay, that gives room to theory 3. Their kinetic energy is a measure of their temperature. Right, there you have it. Temperature of a gas is a measure of their average kinetic energy. You can also put it that way. It means that as the temperature increases, these molecules get more kinetic energy, and then they begin to move faster and begin to exert more pressure on the walls of this container, such that if this container is not strong enough, you're going to have a boom, which means the container is going to explode because the particles will keep on bombarding the walls of the container. Right? So let me talk about 4, the next one. Now, the next one states that the actual volume occupied by the gas is not up to the volume, the real volume of the container. Now let me put that in standard terms. The actual volume occupied by the gas molecules is negligible relative to the volume of the container. Here we have it. The actual volume of the occupied by the gas molecules is negligible relative to the volume of the container. Alright, so it simply means that, let's just assume that this is the container. Okay, now you know that the molecules are actually scattered, and they keep on moving. So if we actually compress them, we place something heavy on this. Okay, this give room to some laws like Charles' law, Boyle's law, but don't worry, I will explain those laws in other videos. All right, so let's continue. If we actually compress them, okay, now the actual volume occupied by them is negligible to the real volume of the container. All right, let's continue. Now, the fifth one states that the coercive forces between them are negligible. By them, I mean the gas molecules. Right, I made a mistake there. The gas molecules are negligible. That means you can neglect them because they don't actually seem to be there. When the gas molecules keep on moving around them, they hit each other, they bounce. Now, the coercive forces are actually forces that are supposed to attract them. Forces that attract molecules are like molecules. That's the definition of coercive forces. Okay, I'll be talking about the coercive forces in the next video, when I'll also be talking about the states of matter. So thanks for watching, guys. Please like and subscribe. Thank you very much.